Hi everyone, welcome to Old School Chemistry. We're going to do another ALEKS topic looking at alkanes. This topic is a mouthful. It is using multiplying affixes in the names of branched alkanes. Now a little reminder for you how we name these branched alkanes. I have a list, 5 steps for us. First, we have to identify the longest parent chain. That's the longest continuous string of carbons. And remember, it doesn't have to be straight, just the longest continuous chain of carbons. Number 2, we're going to identify the substituents that are attached to that parent chain. Number 3, we number the parent chain so that the sum of the substituents gives us the smallest number. Number 4, we list those substituents alphabetically. And then number 5, remember, here's our pattern. We always give the location of the substituent, like an address, then the substituent, and then our parent chain. And just a reminder, on the parent chain, this is going to be the prefix, how many carbons are in that parent chain, and the suffix, what types of bonds are in that parent chain. In this example, they're all single bonds, so they're alkanes. The ending is A-N-E, ane. And then just a reminder, if you have multiples of the same substituent, we have to add the Greek prefixes di, tri, tetra. And we'll look at an example of that. So let's jump in. We're going to do 3 examples today. Our first one, hey, that's a pretty good compound right there. Let's start counting. We want to find our parent chain, the longest continuous chain of carbons. I tend to always go linear straight for my very first counting. 1, 2, 3, 4, 5, 6, okay? Let's do 1, 2, 3, 4, 5, 6, 7. All right, that's going to be longer. About 1, 2, 3, 4, 5, 6, 7. Okay, those are both 7, which means we can choose either one. We'll get the same answer, with the exception if you ever have an isopropyl as an option for your substituent. But the other way you count, you don't have an isopropyl, try and avoid isopropyls. Okay, I'll just plant that little seed. So we have 7 this way, or we had 7 this way. Okay, great. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think we found our longest is going to be 7. So for my brain, you could do either one. You could do this one, or you could do this one. For my brain, I like this one. So I'm going to highlight that one for us, okay? This is going to be our parent chain right there, our 7. So right away, I start thinking, okay, my parent chain, 7, hept, all single bonds, ane. My parent chain is going to be heptane. So let's identify our substituents. What's attached to that parent chain? Well, I see 1 carbon. Remember, that's going to be a methyl. Meth meaning 1, YL meaning substituent, a methyl group. Then I have 2 carbons right here. 2 carbons, our prefix is eth. The ending for a substituent, il, ethyl. This is an ethyl group. And then we've got 3. This is kind of exciting. 3 carbons. Our prefix is prop, P-R-O-P, is a substituent, so the ending is il, propyl, a propyl group. Okay, fantastic. Now we're going to number. We want to give the smallest sum for their locations to each of these substituents. So we have one of 2 options. I can either number, starting right down here, 1, 2, 3, 4, 5, 6, 7. That would give me for my substituents a 3 plus a 4 plus a 4 is going to give me 11. Okay, now let's try going right to left and see what we get. So I'm going to have a 1, 2, 3, 4, 5, 6, 7. That's going to give me a 5 plus a 4 plus a 4 is 13. Going from left to right is going to be our smallest sum. So I'm going to number with this purple, left to right, left to right. Okay, nice. Let me erase those pink so it's not confusing for us. Now we can put all of this together, okay? I'm going to erase all of this so we can begin. So we're going to go with alphabetical order. Remember, that's so important. Sometimes students want to number numerically, but you list these in alphabetical order. So E comes before M, which comes before P. Let's go ahead and write it out. So my ethyl was at the number 4 carbon, 1, 2, 3, 4. So this will be 4-ethyl. Just a reminder, we use dashes between numbers and letters, commas between numbers and numbers. 4-ethyl. Then I'm going to go to my methyl group, which is at the 1, 2, 3. So dash, separating my letter and my number, 3-methyl. Now we're going to go to the propyl, that was on the 4 carbon, dash, 4-propyl. And now I can say the whole parent chain. Again, 7 carbons, hept, all single bonds, ane. Wow, so let's look at this. We have a 4-ethyl, 3-methyl, 4-propyl, heptane. Very good. Okay, nice. Let's do another one. Okay. Is another chunky one. Nice. And do you know what? I'm going to clean that off. Sometimes the purple marker doesn't like to come off. I've had students ask me, what's the solution that I use to clean my board? Are you ready for it? Water. Whiteboards have an oil put on them, so water takes it off great. Okay, let's go through our steps. We're going to find our longest carbon chain. Let's go in the middle. That's always where I start. 1, 2, 3, 4, 5, 6, 7. Oh, 7 again. Let's try 1, 2, 3, 4, 5, 6, 7. Okay, also 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 7 is going to be our longest. We have 2 options. I could either go here or I could go here. When I have a choice, I always take this straight chain just because my brain is a little bit easier. Okay, so let's go ahead and identify those substituents. I have 2 carbons, thinking what's the prefix for 2? Eth, it's an ethyl group. And then here, 3 carbons, that prefix for 3, prop, so that's a propyl group. Those are my 2 substituents. What's attached, the carbons that are attached to that parent chain. Now numbering. Oh, this is kind of, I like to say it's like a palindrome. Notice we could number it either way. I could go 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. It doesn't matter. If I go left to right or right to left, I'm going to get the same numbers. We're going to be at that 4 carbon. So now we can put it all together. Remember, we're going to name substituents alphabetically. E comes before P. So this will be a 4-ethyl dash 4-propyl. Notice those dashes between the numbers and the letters. And then I put in my parent chain, hept, for 7 carbons, ane, all single bonded. So this is a 4-ethyl, 4-propyl, heptane. Nice. Let's do another one. We'll clean this off with water too. And what I've written up here, that's actually what you would type inside of that ALEKS. Okay. Ooh, kind of cool. Looks like a plus sign. So let's jump in, find that longest chain. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. However we count, we're going to get the longest chain is 3. So I'm going to use the straight option, just because it's easier for my brain to process. Ooh, and then look at this. This is also going to be like that palindrome, that it doesn't matter if you number left to right or right to left, you're going to get the same sum. So 1, 2, 3, so that would be a 2 and 2 is 4, or 1, 2, 3, 2 and 2 is 4. Again, my brain, I read left to right, so I'm going to say 1, 2, 3. Now this is a really good example of multiples of the same substituent. I have a methyl and a methyl. We have 2 methyl groups. 2 methyl groups. So how we do this? We have to tell the reader there's 2 groups. We have to tell them where both of them are located. And so the one thing that we add to this that feels just a little bit different for students is the prefix di. Dimethyl, because I've got 2 of the same substituent. Okay, so watch this. These are both on that 2 carbon. So this is going to be, I have to tell the reader where both of those are. It's going to be a 2, 2, separate numbers with a comma, dash, watch this, dimethyl. I will tell you right now from experience, that die is what students will miss. They'll give me the 2 and the 2. They know that they're both attached to that 2 carbon, and they forget the die. So be careful on that. 2,2-dimethyl. My longest chain is 3, which that prefix is prop. All single bonds, ane. So this is a 2,2-dimethyl propane. Excellent. Very, very good. Well done. So proud of you. Have a terrific day. If you haven't already, please like and subscribe. I'll see you next time. Bye.